Okay, now that we took the time in 4.1 to add and subtract, now we're going to take a look at multiplying polynomials. And then we will explore division a little bit later. So remember, a polynomial has one or more terms. So we've already talked about how to multiply one term times one term. We've also talked about how to distribute, okay? So what we want to practice now is multiplying polynomials that have several terms. So just to refresh your memory, okay, a monomial, mono means one. So it's a polynomial having one term. Terms are separated by plus or minus, but since we only have one term, we just have a constant number, a variable, or a constant and a variable. A binomial, that prefix bi means two. So this would be a polynomial having two terms. So there will be a plus or minus in the problem because we have to separate it and get two terms. A trinomial is a polynomial having three terms. And anything beyond a trinomial we just call polynomial, meaning many terms. All right? So the easiest way is to actually just practice, and then we'll take a look at, there are some shortcuts. Your book, they're on page 175. You do not have to know a shortcut if you know the concept. So for example, let us simplify, and I'm going to start with a monomial times a binomial. So I have one term being multiplied by two terms. Well, the concept is the distributive property. So I'm going to write this out, and then eventually you'll probably be doing it probably mentally. So I have an x squared times 3x to the third plus an x squared times 2x. And then I now have two terms, because terms are separated by a plus or minus. So with this first term, we'll just do what we did last section. Since the bases are the same, I have a 1 times 3. Since the bases are the same and we're multiplying, we add exponents. Multiply the coefficients 2. Since the bases are the same, we add exponents. Now I have two terms. They are not like terms because the degrees of the x's are different. So since this is an x to the 5th degree and this is an x to the 3rd degree, they're different, so we are finished. And it is proper to put them in descending order by degree. So that's if we have one term times two terms. Let's say we have two terms, 2x plus 3 times two terms, 3x minus 1. And you'll notice I'm not using large numbers because we're looking at the process and the concept. Now, you can always distribute, always. And that's what we're going to do. We're first going to distribute the 2x times the 3x. Then I'm going to distribute the 2x times the negative 1. Now that I've distributed that first term to both of the terms in the second factor, I'm now going to distribute the positive 3 times the first term 3x and the positive 3 times the last term negative 1. Okay? So now I have 4 terms. Some of you may recognize what I just did. I just did an acronym FOIL, which we'll talk about in a moment. Now if I'm going to treat each one separately. 6x squared minus 2x plus 9x minus 3. Keep combining like terms, and we are finished. Okay. So all we did was the distributive property. I'm going to write this another way. I'll come back to a moment to our acronym. Let's say I give you 3x minus 5 quantity squared. Now be careful. This is not one term, so I cannot simply square everything on the inside like I did last section. This has 2 terms. So I recommend that you write this out, 3x minus 5, 3x minus 5, and now go ahead and use the distribution property. First, I'm going to distribute 3x to both, plus 3x times negative 5. Then I'm going to go back and I'm going to distribute the negative 5 to the 3x, and I'm going to distribute the negative 5 to the negative 5. Now I have 4 terms. This will give me a 9x squared. 3 times negative 5 is a negative 15x. Notice I get the same thing again. Negative times negative is a positive 25. So this is how we square a binomial. So I have a perfect square binomial. When in doubt, write it out and just use the distributive property. Okay? Some of you may be familiar with an acronym called FOIL, F-O-I-L. You do not have to use it. You never have to use it, but it's a nice way to help whenever you're multiplying a binomial times a binomial. If, for example, I have a binomial, 2 terms, let's say x plus 7 times 2x minus 3. FOIL, the acronym FOIL, only works with a binomial times a binomial. Okay? The F stands for the first terms. So if I multiply the first terms, x times 2x, that's my first term. The O represents the outer or the outside terms. So the outside terms would be the x and the negative 3. The I in the word FOIL, sorry, this cap won't come off. The I represents the inside terms. The innermost terms are the ones on the inside, the 7 and the 2x. And then the L for the word FOIL represents the last terms. So the last terms would be the last one in each one of these. the 7 times negative 3. So then if we simplify each term, x times 2x is 2x squared minus a 3x plus a 14x minus 21. And then with FOIL, you can usually combine your inner and your outer terms. So you'll notice both of these are like terms because they're both x to the first. So we're left with a 2x squared plus 11x minus 21. So sometimes you might hear your friends talk about FOIL. Okay? I also learned it as the claw. Think about like a lobster claw. Kind of looks like a claw. Kind of looks like a claw. Okay? So you may also have learned it that way or never before. So that's what that acronym FOIL means. Do you need to use it? No. If you would like to use it, that's fine. Okay? So I'm going to do it again. Before I move on to something that's got like a binomial and a trinomial. So let's say I do another perfect square binomial. So maybe 2x plus 5 squared. I personally like to write it out. This is the same as 2x plus 5, 2x plus 5. And now I'm going to think about the acronym FOIL. First would be the first term times the first term. 2x times 2x. Outside would be the outermost terms, which is a positive 2x times a positive 5. The inside would be the positive 5 and the positive 2x, the innermost terms. And then the last terms in each factor would be a positive 5 times a positive 5. And so then we are left with a 4x squared plus 10x. Notice that's the same again in a binomial that has been squared. So we are left with 4x squared plus 20x's plus 25. So most of this section is practicing multiplication of binomials or a monomial times a binomial. Okay. Now, we also have some special binomials, and I do want to do this one. Because notice what happens if I take a binomial like x plus 4 and I multiply it by x minus 4. So notice the terms are the same. X and 4. X and 4. But I have a sum and a difference. So I have the sum and difference of the same two terms. Don't memorize, just analyze and watch what's going to happen. If we go ahead and we can either use the acronym or not, if I multiply the first term times the first term, I get x times x, which is x squared. If I multiply the outermost terms, I get an x times negative 4, which is negative 4x. The innermost terms are a positive 4 times x, and the last term is a positive 4 times a negative 4. And notice what will happen whenever you multiply the sum and difference of the same two terms. You'll notice that the inside and the outside cancel, and we're left with the difference of two perfect squares. Okay? So you'll get to practice some of those. And again, the book on page 175, gives you 3 of them that kind of have shortcuts. But again, you don't memorize shortcuts if you know how to work it out. And then the last problem or two I want to look at is, what do you do when you have larger, you know what, before I do that, I want to bounce off of this one. Here, let's look at this. I want to see what you might do. I want to piggyback, also called springboard. Sometimes you hear of it as scaffolding if you're in an English class. I want to springboard off of this idea. Anytime you have the sum and difference of two terms. And I want to look at number 46. Some of you are like, what? 46? Oh no. Look at this one. I would like you to multiply out x plus y squared, x minus y squared. Now the long way, x plus y squared means x plus y times x plus y. We could FOIL that out and we could get an answer. Then I would have to multiply it by x minus y, and then I'd have to multiply it by x minus y again. This could be long and tedious. But remember, this is all multiplication, and multiplication is commutative. So I'm going to commute, and I'm going to rewrite. I'm going to pair them up. I'm going to rewrite, I'm going to switch these middle two terms. I'm going to call this x plus y times x minus y. And then I'm going to multiply that by x plus y times x minus y. And now I can incorporate what we just learned. So if I do this first two, I have the sum and difference of two terms. So if I FOIL, first terms, x squared. Outside term, negative xy. Inside term, positive xy. Last term, negative y squared. And because these are the sum and difference of the same two terms, these will always cancel out. So we are left with x squared minus y squared. Well, notice right here we have the same thing. So I'm just going to fast forward and I'm going to get the exact same result. And that's not that bad to have to FOIL together. I didn't realize that this was off the board, sorry. This says FOIL and this says rewrite. So I'm going to quote FOIL again. First term, x squared times x squared. Outermost term, x squared times negative y squared. Innermost term, negative y squared times x squared. And last term, opposite of y squared times opposite of y squared. X to the fourth, go alphabetical, minus x squared y squared, go alphabetical, minus x squared y squared. Negative times a negative is a positive y to the fourth. And now your inside terms are like terms. So I have two of those. and a y to the 4th. Okay. All right. All right, so we can distribute. Okay. And then I want to show you how to do, I'm just sort of choosing a number here, like number 44. Number 44, I'm going to do 2 different ways. And just to show you 2 different ways to organize your work, either way is fine. It doesn't matter which way you choose. Let me see what variables they chose. 44s are A's and B's, so that's not bad. So I'd like to do number 44 2 different ways. Number 44, and this will be our last example, because then the challenge problems at the end you're familiar with. I just want you to think about them before I tell you how to do them. 44 says our first factor is a plus b. Our second factor is a to the 3rd minus a squared b plus ab squared minus b to the 3rd. Now we're going to look at this 2 different ways. First is horizontally. So horizontally, let's distribute. Okay? So if I first distribute a to everything, we're going to get a times a to the 3rd plus a times opposite of a squared b plus a times the 3rd term plus a times the 4th term. Now that's once we distribute the a. Now let's go through and distribute the 2nd term of b to everything. B times the 1st term, b times the 2nd term, b times the 3rd term, b times the 4th term. And this is a very horizontal way that will always work. And now let's simplify each term and then combine like terms. A to the 4, a to the 3, b to the 1st, a to the 2nd, b to the 2nd, a, b to the 3rd. Just simplifying each term. A to the 3rd b, it's proper to go alphabetical. A to the 2nd, b to the 2nd, I just commuted those. A, b to the 3rd. And now let's combine like terms. Well, I have an a to the 4th term, but I do not have any other term that is a to the 4th. I have an a to the 3rd term, a to the 3, b to the 1, a to the 3, b to the 1. So if I combine those together, those cancel because they're opposites. Then I have a positive a squared b squared and a negative a squared b squared. Positive and a negative, well, those cancel. And then I notice the ab to the third, which is negative, cancels with the ab to the third, which is positive. So those are gone. And I'm left with my last term of b to the fourth. Now, it doesn't always work that way, but I wanted to demonstrate what it was like to write them all out horizontally. Okay? So that's a horizontal approach. It always works. Okay, so this was a horizontal approach. Always works, but sometimes it can go all the way across your paper and you run out of room. But we could also do the same thing vertically. We could say, okay, first, I'm going to do the same thing. I'm going to distribute the a to everything. Right? A times a to the third, a to the fourth. A times our second term, a to the third b. A times our third term, a squared b squared. A times our last term, ab cubed. But now this time I'm going to add vertically. I'm going to line them up. When I distribute b, I'm going to get a to the third b. Here's one right here. Then I'm going to distribute the b. I'm going to get a squared b squared. Then I'm going to distribute to the third term. I'm going to get an ab to the third. Then I'm going to distribute to the last term. And this time, I'm going to choose to add them vertically. And because I already aligned like terms, you'll notice I end up with the first term of a to the fourth. These reduced, these reduced, these reduced, or canceled. And I'm left with my last term. So I'm left with, again, a to the fourth, b to the fourth. So you don't have to, but you might consider setting them up, as you expand them, you might consider setting them up vertically. And then it's through the elimination process that will combine the like terms. Okay? So of course, you're welcome to do examples in the book, read through the examples there. But take a look at these, you guys, and just practice doing some of the multiplication using the laws of exponents. Okay? All right, until next time.